Good evening, everyone.
Hello.
Hello. So let's wait a couple of minutes more before starting. And then we go.
Okay.
Today, unfortunately, Valentina can be the host of the seminars, and I am in charge of being the host and the chair for today, which is an honor to me, and also a pleasure, of course. I hope it would be the same for you as well. And that's it. So let's really wait another couple of minutes, and then when I can introduce both speakers for today, and I leave the room to science. Okay, we can start. The 2 minutes are already gone. So welcome everyone to this is one of the seminar in the context of the Polifonia project. Most of you are already used on the general pattern of this seminar series. So basically we have 2 speakers for today. One is an external host, and is David Chaves-Fraga. I hope that I pronounced well your name. And then we have an internal researcher, internal with respect to the project, which is Enrico Daga. As I said before, typically these seminars are hosted and chaired by Valentina Presutti, that unfortunately cannot be part of the seminar today, and I am in charge of playing the role of being your chair for today and having the difficult role of substituting efficiently Valentina, which is always a challenging task. So the organization is the following. We have so these 2 talks. You have, David and Enrico, 20 minutes each for your talk, plus 10 minutes each for questions from the audience. I will advise you when you are more or less 1 minute to go to the end of your talk. So I will tell you when the time is finished. So as I said, I would like to leave the stage first to David, who is the external host, and then to Enrico. So it's a pleasure to me to introduce David, who is a researcher, a postdoctoral researcher at Leuven in Belgium, right? He works mainly on optimizing the generation of knowledge graphs from heterogeneous data on the web using mapping languages, and his talk will be focused on technologies for enabling mapping-based transformation and generation of knowledge graphs. So David, when you are ready, you can share the screen. I hope you can. In case you cannot, okay, you can.
Okay, perfect. I think that you can see my screen right now. So yeah, let me open here. Okay. Okay, perfect. Good. So thank you very much for the introduction. It is a pleasure, and thank you, Enrico, for the invitation as well to give this talk. I'm really happy to be here with all of you. Yeah. So yeah, basically, the idea of today is that I'm as said before, I mainly work on the construction of knowledge graphs. I mean, to create RDF, mainly RDF-based knowledge graphs using mapping rules. Okay, we will go and dig in a bit over what are mapping rules and why are important. So that will be the mainly topic of today. I mean, it is already that I have a bit of the introduction, but a bit more about myself. I mean, I did the PhD in Madrid in the ontology engineering group under the supervision of Oscar Corcho, which was mainly focusing on the optimization and evaluation and creation of benchmarkings for a new generation of engines that generate RDF based knowledge graphs using declarative mapping rules. And then since finished the PhD, I moved to to the KU Leuven in Belgium to work with together with Anastasia Dimou as a postdoctoral researcher there. I'm a young postdoctoral, so I have both affiliation. I'm still part of Madrid because I'm funded by them to do this kind of internship, long internship with in Belgium, and also I'm co-chairing since 2 years ago. 3 years ago, the W3C community group of knowledge graph construction. We are creating events. I mean, if you were in ESWC last, like a few weeks ago, we were giving a tutorial on this topic as well. And I am also organizing some workshops in the topic of transport data and also in this of the knowledge graph construction. So yeah. The main idea is, let's go directly into the details. So yeah, the main idea is that we have a lot of data around the web. I mean, in open data portals in different formats, we have relational databases that we want to incorporate or integrate in a knowledge graph. And we have another knowledge graphs like DBpedia. We have REST APIs. I mean, there are very big and heterogeneous data sources around the web that we want to be queryable, usually, I mean, with our semantic web technologies. But usually during this process, there are some of features that we want to achieve, right? I mean, this process of integrating data is well known as well from the database world. That wants to be efficient and scalable. These are maybe the main features of this process, but as well, it is important to that this process of creating the knowledge graph is maintainable, is robust, and also it's reproducible. So yeah, my talk would be that giving like some examples and some experience that we had in the previous years about these last three main features. They putting the focus on process that will be maintainable, robust, and reproducible. So let's go to a scenario where we want to create this knowledge graph. Okay, and the first thing that we can think on doing it without any knowledge is like, yeah, we have an ontology that represents the global view that integrates all of our data. And then we have a lot of different sources that want to be compliant with the ontology. And we want to create the knowledge graph. And usually the first approach that we can follow, and that still is followed a lot in the literature and by a lot of projects, it's that let's code in it. Okay, let's take in like a library that supports RDF and that enables to parse these kind of sources like CSV, JSON, and creates an ad-hoc script or an ad-hoc program that integrates all of this data. But the problem of this is that, it could be efficient, it could be scalable. It depends, of course, in the programmer of this script. But in our experience, the last three features that I mentioned already are difficult to get it, because I mean, if it's a program, of course, the maintainability relies on the programmer. It's less reproducible because if they change sources or they change the ontology, you have to go into the code to change all of that features, etc. So yeah, we should think in other steps or other process to that allows to enhance these kind of features. So the mainly idea is that this, as I said, this knowledge graph construction process could be seen like a data integration system, a typical one, okay, where we have like an overview, which is represented by the ontology. And then we have the mappings. And we are going to put the focus in very detail over the mappings here, because the mappings are declarative. I mean, I'm not talking about any kind of ontology. It could be like an SPARQL query, it could be like rules in a standard like R4ML that relates semantically the sources and ontology. So you have to find the equivalent column or key in your data to the feature or the property of your ontology. Usually, it is a user. I mean, right now it's done manually, which do this relationship, and then we rely or leave it for an engine that it's able to parse this kind of documents. Okay. In the previous contributions to the state of the art in this was mainly focused on the efficiency and the scalability of this process. So we can think about, for example, this well-known engine like OnTop, which it's always focused on querying relational databases from an ontology, very efficient, and there are other solutions where we're focused on the scalability as well. But still, they were not put a lot of focus on the other side of the process, which is the creation of the mapping rules. So again, the last three features we have to deal still with them. So yeah, what we are starting is to put the focus on this process where the users are involved. So the main idea here is like having like procedures, workflows, sustainable workflows to create these mapping rules, because we figured out that it's not an easy task, and it's the currently bottleneck on the creation of the knowledge graphs. So if we achieve this, if we can improve all of this process and making it better, we will have or fix it all of the problems, I think, and we will have like a good data transformation pipeline towards the knowledge graph. It was like a brief introduction of the idea and the motivation. And right now, I'm going to give you like three different scenarios, briefly scenarios, from the user perspective. Okay, so I'm going to talk about two different projects that we working on that maybe will also help you during the creation of the knowledge graph in this project as well. So yeah, the idea is that to put the focus on the users, and so a first scenario, which was a project like 1 or 2 years ago, is that like a company wants to create a knowledge graph from its database, but we didn't have any vocabulary, any ontology to represent that data, and the domain experts from the company that were working with us and providing the knowledge of that domain, they weren't have the technical skills. I mean, they were not able to deal with data as well. A second scenario, I mean, the second project was that externally from that project, the vocabulary and ontology was defined. For example, if you want to as well to follow like a standard, like SSN ontology or another one that would be a standard. And also in this second scenario, the domain experts had technical skills. There could be like different relationships. I mean, another scenario that could be like with no ontology, but with domain experts. I mean, but these ones are the ones that we were dealing with, and I left my experience here. And the last one that it's a promising, let's say, a scenario that was not still not in real world. That it's like instead of having an ontology, having a knowledge graph with data. I mean, the ontology, but also the knowledge graph with data, for example, the Wikipedia. And we want to reduce the effort of the domain experts involved in the construction of the knowledge graph. Okay, so let's describe briefly the first scenario where the data come from the company, and they ask us for creating an ontology network. So we had to develop the ontology network, and in here we identified of course the role of the domain experts. We also have the role of the ontology engineer and the knowledge engineer, which is the let's say a bridge between knowledge and data engineering. So here the one that it's taking care of the ontology, it's also been helping by the knowledge engineer in this process to understand which is the data, because we followed like a bottom-up approach. Okay, so we understand the data and we generate the ontology from the data. And then the same person who helps to create the ontology network also helps to also did the construction of the declarative mapping rules, and finally the knowledge graph. At the end, the objective was to create like a question answering system here, and it was the demanding of the partner in this project. From this project, very briefly, what we learned is that if we don't have like an ontology, the effort, I mean, we are developing the ontology, so we know, I mean, and we are going deep into the domain with the development of the ontology network. So here the creation of the mapping rules are not taking a lot of time, because here the bottleneck was the ontology network. And during this process of the creation of the ontology, we continuously were creating as well the mappings and cleaning them and ensuring that they generate high quality data, RDF data. But our lessons learned in this process were that was simple. I mean, to use simple but useful tools. I will talk about this later on. And the domain experts, if they don't have any technical skills, let's move it only to the conceptualization of the ontology, and then they don't care about any technology that we are using. The problem here is that to having like the maintainable knowledge graph, it will be difficult to guarantee, because the experts, I mean the people from the partners, doesn't have like a technical background. The second scenario was we were trying to construct like a knowledge graph for research performing organizations, these organizations that gives technological support, in this case for universities. So there is like a big project in Spain that we are trying to create like an ontology to cover all of the information from all of these kind of organizations and have like a central repository with all of these knowledge graphs. So on one hand, we had an ontology that we didn't develop. So that is a problem, because we have to follow that ontology, but it was not developed by us. In the moment that we started the ontology, the project, sorry, it was in a very immature state, and it needs to change. The documentation was not very good. And in the other hand, provided by the partner that wants to create the RDF based on this ontology, was like a huge database in Oracle with almost 2,000 tables. It was good because Oracle supports RTML mappings. So from that side, the decision of the technological decisions were really simple. We needed to think about a workflow that fits on this context, and it's sustainable and can create at the end the knowledge graph. So I mean, we started to have like an engine that automatically generates some mapping templates extracted from the ontology, so helping the knowledge engineering to fill all of the equivalent relations between the ontology and the data sources. And then we divide every mapping by entity, because there were like a lot of entities and there was like very complex environment. We starting to fill in all of the mapping templates with the database instance and testing them by each entity of the ontology. And then mostly at the end, we started to have meetings with the domain experts that had knowledge background from the database to understand if the mappings were good, to ensure that we are mapping correctly all of the data. So I think that this pipeline works pretty good. It needs, I mean, to adapt to next projects will need a bit of adaptation. But in this case, I mean, it was like a pipeline that works pretty good and ensures that all of the mappings were generated correctly. I mean, in this, we generate a lot of mapping rules. I mean, it took us like almost 7 months to generate all of these rules to generate to create the knowledge graph. And yeah, it was really good to have people involvement from the company that had technical knowledge. So they were like creating the views for us in the relational database, etc., etc. And very briefly, we are dealing lastly with this last scenario in which we want to reduce this time of 7 months having one person creating that rules, which is the bottleneck. I mean, we are ensuring that the knowledge graph will be high quality. I mean, the data that we are generating will be high quality, but it's super demanding. So yeah, with this kind of solutions that appear of semantic annotations, like sometimes challenge, we are exploring right now how can we create knowledge graphs, but automating some of the steps. And this is the last scenario we are trying to. This is more research, let's say, but let's see how we can achieve it. Because the idea is to not remove the rules, but to work in a hybrid mode where we are able to automate some of the tasks, and that help us to incorporate or create some of the templates and sort of drafts in the declarative mapping rules, because we believe that these declarative rules are really important to ensure that the knowledge graphs are constructed.
I mean, you have 1 minute left.
And I'm going to the conclusions right now. So it was
just to inform you and not to bother you.
Thank you. So yeah, I think that it was briefly. I only want to give like an idea of the kind of real work that we are currently doing, and it's even now it's super demanding. So we have a lot of projects where we have to involve people that understand the technology part, but also the conceptualization part, to ensure that we are generating knowledge graph that then can put it in production. And it's important as well to have to take into account the background of the people that it's going to be involved in the project. And this process can be adaptable to any of the process. Last but not least, a bit of advertisement. I mean, if you are or you want to know more or get involved, just join us in the W3C working group, community group, because we are working towards a new generation of mapping rules and systems, and we have created like a full list of tools that are able to generate these knowledge graphs in that GitHub link. Then I will share the slides, and I think that's all from my side.
Thank you, David.
I fit the time.
Yeah, you were perfect on time. So thank you for your qualitative talking that was also respectful with respect to timing. Is there any question from the audience? You can raise your hand, and then I will try to follow the order of hands raised. Okay, first we have Giorgia Lodi. So Giorgia, you can go straight to the question.
Okay, I have many actually. I'm very curious about the templates that you mentioned, okay, because it seems to me that this stuff of the templates is the tricky part that allows you to speed up also the work of this creation of the mapping rules, no? Mm-hmm. Is this work available about the template? Is somehow related to RML? Can you provide more details
definitely.
on this?
Yeah, the link is there. I mean, it's really, really simple. It was like an idea. Indeed, was when I was teaching this, I've realized that most of the rules that my students have to follow to create the mapping rules are really simple. So basically, this script that it's super basic creates an RML template without filling the instance of the CSV file, the database, but it puts you in a RML mapping all of the classes, all of the properties, and all of the joins that should be there. Then, of course, there is a manual part that you have to know if the data is in the database, and et cetera, et cetera. But in this case, I mean, it's really, really simple, but it helped us a lot. Because you don't have to start from scratch the mapping. So you have something.
That's great, very interesting. Can I continue with my questions, Andrea?
Yeah, go. When we move to the
I would like also to understand the amount of data that you deal with in this project. Are we speaking about big data, for example? Because I tell you, we have some projects where we have really big data, okay? So yeah, in this case, you have this huge database. And we have already we have also some cases of this, and we try to use some tools like RML Streamer, but there are limitations. And so I was wondering if you have a case with very large data sets, and in that case, your experience, you know, in terms of producing the knowledge graph. It can be simple, but then how to query this also sometimes is very strong. It takes time. And this sometimes let people, also not technical people, perceive the knowledge graph like, oh, I cannot use it because I cannot query because it's too big and I cannot get advantage from it.
Mm-hmm. Definitely complex scenarios where you have to do this, it's difficult. I mean, in terms of performance and scalability, we have developed this engine, which we tested in over the benchmarks, and in the part, it's only in materialization, so generating the proper RDF. So in our testing, it works pretty good. Of course, it depends always on your data set, and it's difficult to recommend you to say, no, use this engine, use the other engine. I mean, it depends. But in our experience, and the paper was just accepted like 2 or 3 weeks ago. So you have all of the experiments there. You can take a look. I mean, it's openly available in the Semantic Web Journal. And in our experience, it works pretty well. In the other side, I mean, usually when you have a big data set, if it's in a relational database, you can always say, yeah, let's go through a virtual approach, right? So you only translate the data and generated it. From our side, our experiences is that most of the companies want the data, the materialized data. They don't want the virtual approach. And at this moment, I mean, I would say that maybe some of the operators from SPARQL are not support, or you have some problems. So yeah, it's sometimes difficult to take the decision here.
Okay, next question. So Justin.
Oh, thanks. Hi, David.
Hi.
Yeah, I also had a question about the mapping templates, the OWL to YARML. In my experience, when I do knowledge graph construction from, say, a tabular source, maybe CSV, I work with subject matter experts. I kind of understand what the data, what it means, and then I have sort of like, I often open up Protégé and I look at the target ontology, and I'm saying, okay, here's the classes that I can reference. Here are the data properties. Here are the object properties, and then I go from there. I express the tabular data as RDF, but usually at no time am I interested in a template to help me, because you know what I mean? Because it's like, I have to interpret every table in the database and look at each column in the CSV. So I'm just wondering, what is it that the template gets you? Because I don't feel like I've come across cases where I needed templates, right? Because I know what I have. I have classes, data properties, and object properties, and I'm targeting those. So is the template more on the source side? Does it help you with the source? Because I have a hard time seeing how it helps you with the target.
Yeah, definitely. It's something that we have to explore, and we are moving towards that. And also it's something that with this automation, we want to explore it. But right now it's only from the part of the ontology. I mean, I can show you like a template if, let me close this. But the template, I mean, I think that you are aware of JARM syntax. So the templates are basically this, and it's like you have a subject, but you have the class and all of the data properties, and then the object properties generated. So the script, it's only go through the ontology. It doesn't do anything right now with the source. Of course, that's the most difficult part, but at the end, with this, you don't have to, I mean, it's like reducing a bit of the time, let's say.
Okay.
Well, thanks, David.
Any other question? So if no other question, I have one question which is also focused on, let's say, on the templating mechanism that you presented. But so your template mechanism is mainly focused on targeting the ontology, right? On the other side, we also have data. I'm wondering if there's, I mean, in your methodology, any approach or possible solution for dealing with the generation of templates or draft mapping rules directly from data, which is typically the most complex task. So as you also said, you took something like 6 months or something like that for generating mapping rules on top of your data, which is a sort of bottleneck in the whole knowledge graph construction process.
Yeah, definitely. I mean, there were like in the state of the art when I think 10 years ago, when W3C, the R2ML W3C recommendation was like a recommendation, actual recommendation, they started to rely on the database schema to automatically do kind of drafts and recommendations of over the mappings. I mean, with the input data sources. The problem is that they rely a lot over the schema, and when you have like node schema from CSV, for example, it's really difficult. And our experience at the end, it's like, yeah, if you want to ensure that the quality of the data will be high, it's better to do manually than recommendation. But we are still having right now, currently, some projects where we are investigating, for example, if the database is very well documented, like with this last approach, and we have a very well documented ontology, maybe some matching, some string matching or something alike could help. But I think at this moment it's very difficult. It's the problem of in SEMTAP you have a lot of data, so you can annotate. The problem here is that you don't have data that could be used for training. So it's really difficult to do it.
Any other question? So I really the last one, then we move to the next speaker, and it's about so it's very interesting that mapping rules in this kind of solutions are basically RDF themselves, so they are somehow knowledge graphs. So in principle, it would be fair to reuse or to reuse or to share mappings as patterns or as reusable artifacts for knowledge graph construction, more from the knowledge construction process, of course, than knowledge reuse per se. But I mean, I think that what is the the state of the art on this direction, or do you think they are still used as isolated artifacts instead of being part of typical reuse and sharing, which is more typical that for real data?
It's always a good question that they made. I mean, and indeed in ESWC we were discussing a lot about this, having like not a centralized, but like an application where you can upload all of the mapping rules, so you have then a corpus, and then you can start to recommend its rules. It was something that we did like 5 years ago. I think it was called Mappingpedia. And the idea was to upload the data and to help people to generate the mapping rules. Right now that it's stopped, and the problem that we had, for example, in the W3C community group, is that most of the partners don't want to share the mappings, because usually the data is private. So yeah, hopefully, there were like movements towards the creation of mapping rules in Open Data Portal, for example, and we will finally have like a big corpus that we can use then to our kind of recommendation or automation of the creation of the mapping rules.
Okay, thank you, David. I would say let's thank with a big applause our speaker.
Thank you.
One, but it is deserved. So and now let me introduce Enrico Daga, that first of all is a friend of mine, and actually is one of the friend of mine that I love spending time with. Especially spare time, but it is very focused on his research, and he's an expert in knowledge engineering. The first time I met Enrico, it was in 2009 or 10, something like that, so more than 10 years ago. He was working at CNR at that time, and then we were both involved in interactive knowledge stack. That was a project, and a new project, fortunately an ended, a finished project. And I think that it will introduce us to SPARQL Anything. So I leave the stage and presentation to Enrico.
Okay, thank you, Andrea. Can you hear me first? Yeah.
Yes.
Yes, you can hear me. All right. Can you see my slide?
Everything works fine.
Okay, fantastic. So let's start. So thank you, Andrea, for the sweet introduction. It's a pleasure to be here today, and it's an honor to be the second speaker today and follow David's excellent introduction to knowledge graph construction, which was really helpful to me, because I don't have to spend time in motivating why knowledge graph construction is important, and I can go straight to the point of how we are approaching knowledge graph construction from a slightly a slightly different, but not fundamentally different angle, which is what I'm going to talk about, which is an introduction to what we call the SPARQL Anything. And the title of the talk is Seeing Graphs Everywhere. There's a reason for that. And hopefully this will be explained in the next few minutes. So our reflection on knowledge graph construction has started in the context of cultural heritage projects, particularly 2 European projects that are running now, for which we have the task of generating a loads of different knowledge graphs covering very different ontologies and a huge variety of different data sources. So essentially our main challenge here was to deal with the heterogeneity at scale. Okay, so and there was this strong accent on building knowledge graphs, so putting all the data together, but doing this is as you can imagine particularly challenging and requires a huge amount of different expertise and knowledge of different type of formats, different technologies, and it's clearly a very tedious work. Particularly in our case, and in case of the cultural heritage, but not only, I think this applies to other domains as well. Content can be anything. So we used to think about open data as CSV, JSON, XML, but actually content in sometimes does not come with a handy format. No, they can be spread in multiple different formats. There is a folder with CSVs and JSON that somehow are interlinked inside. So the CSV points to the JSON files for more content. You can have HTML tables, for example. So some data can be not available as data as such, but is kind of hard-coded into HTML views. There can be formats that don't come with a query language. For like if you want to build a knowledge graph out of bibliographies, there are quite a number of knowledge graph related projects in open science, then you don't have a means to query a BibTeX file, for example. There are formats that are made for presentation, for making it easy to present the information, like Markdown. Markdown is very much used in software documentation. But for example, in Polifonia, we want to build a knowledge graph about the software that we produce, right? So how do we extract this documentation from these files? You know? So we have these competency questions, for example. How do we get them into the knowledge graph? And also there are content that are not formats that bring data of a nature that is quite uncommon for typical knowledge graph construction methods. For example, musical data like scores, and here you have examples. Here you can see examples here of MEI XMLs, and on the left side of the ABC notation. So where there is a bit of metadata about the piece, and then a sequence of chords and measures, etc., etc., etc. So content can be really anything. So what we needed to tackle are quite new requirements in relation to knowledge graph construction. So first of all, we need to support an open-ended set of formats. So we need to find a way to reduce as much as possible the impact of introducing a new format into a knowledge graph construction methodology. And we need to work with ontology engineers, which are experts in knowledge graph and semantic web technologies, but are not necessarily developers. And actually, this is not unique of our projects, but these aspects is common, for example, to many SPARQL users, which from a recent survey, we know that many of them come from non-IT areas, like social science, humanities, biomedical, engineering, or physical sciences. So reducing the learning curve for semantic web experts to access this non-RDF data was essential for us. And also there is also a need for flexibility in what we generate. So we want to generate RDF, we want to generate RDF star now, but sometimes we also want to generate tabular data. So we want to use the knowledge graph as a knowledge mediation somehow approach, and then build, for example, a number of CSV tables to use in a machine learning training pipeline. So the main challenge is, and then there is the challenge of supporting like the ontology engineers while they are developing the ontology. So to reduce as much as possible the kind of the iterations between the conceptual modeling and the actual syntax transformations. Okay. So all these things made us reflect on knowledge graph construction in a bit of a different way. In particularly, we looked at this process, which typically is an iteration process. And also the knowledge graph engineer looks at the source data, designs some mappings or some code, runs the transformation, looks at the output, and then troubleshoots or debug or develops the mappings until all the ontology is filled. Okay, but if we look into this process, we can see that there are two activities that the knowledge graph engineer does. One is translating the content from an original format to RDF, and second, projecting the semantics associated with the domain model and the ontology. So what we have seen is that you can look at this thing by separating the concerns and say, okay, let's try and do the re-engineering, so the format recoding as much as possible automatically, and leave to the user only the task of remodeling, of projecting semantics. So in other words, are we able to access anything, any format, as if it was already RDF, and leave the kind of semantic projection lifting task as an RDF to RDF transformation? So that was our question at some point. And clearly we look into SPARQL because SPARQL is de facto the language for RDF knowledge graph. So if you want a knowledge graph, there is a good chance that you want to query it. No? Therefore, assuming the knowledge of SPARQL was our design choice somehow. So how do we enable that? Okay, so we looked into software engineering here, and we found this concept of a facade. Okay, so a facade is an abstraction that is meant to hide the complexity of the various different implementations, the various different classes in the object-oriented narrative. So how we can use RDF as a facade? So that was our question. So what are the components of RDF, the minimal set of components required to kind of enable this direct access to a different number of formats, right? And this question inspired the design of what we call the facade X. Okay, so we picked a number of RDF primitives, which is container membership properties, which is the lists somehow, the type, and literals. Essentially, we designed this very minimal general purpose facade made of containers, slots, and values, where slots can be either strings or integers, and we designed it in such a way that you can use directly RDF, some direct objects of RDF to compose to represent essentially any serializable data format. Okay. Let's proceed by example first, and then we discuss how we evaluated this. But essentially, this is how we thought about a CSV. Essentially, you can interpret a CSV as a list of lists. We have a component to represent lists, which are RDF container membership properties, and then therefore we can use, and then also we can use CSV headers as keys for RDF properties. And in this way, you can see the graph in a CSV file. Doing this with JSON is even easier somehow, even more intuitive. You can see a JSON file as an RDF graph, and you can see that the two things are really very close to each other. JSON has also some typing, so you can bring the fact that 1978 is a number. And you can do this with the DOM objects like HTML and XML, and you can interpret the DOM tree as a graph, again, when you can have types, and you can even inherit namespaces here, because HTML and XML have the notion of namespaces, so you can use directly some of the URIs that come with the data source. And This is how we can see a BibTeX is a container of key value pairs, which is perfectly approachable with the basic RDF components that we are describing. And then this is an exercise with ABC notation. We haven't implemented this yet, but it's just to show that we can. I've tested this assumption that you can work with container lists and and maps, essentially key value pairs, on a huge variety of data of formats, and still found a solution for your facade design. So if we can do that, then what remains is to bring this directly to the users, okay? And therefore giving to the user a tool for doing their somehow knowledge graph construction loop: observe, model, transform, observe, remodel, and transform. And this can be done with our approach in plain SPARQL. So where we override the service operator with the new SPARQL Anything what's that protocol? Sorry, and in this way we can bring in additional data. We can query this data as if it is RDF. We can mint our entity URIs and build and construct our RDF data by projecting semantics in the target ontology. This is clearly a minimal example, and later I'll show a bit more complex ones. So we implemented this approach on a new tool, which is called SPARQL Anything. You can look at the website and read the docs. There's extensive documentation. And we are currently supporting a good variety of file formats, from very well-structured data to semi-structured or even unstructured data at times. The tool can generate RDF, RDF star, tabular data, and it can transform files, inline content. We can even chain like external commands. It supports querying web APIs. There is an extensive list of function libraries, and actually being built on a standard SPARQL engine, extending it with additional function is very easy. The system supports query templates. You can combine different service flows, so you can build a very, very complex pipeline. I've seen a huge SPARQL query designed by the Polifonia people, and that really is impressive. They really change a huge amount of transformation in a huge SPARQL query. Okay, this is a design choice. You can build a very long SPARQL query, or you can build 100 small SPARQL queries and then put the data all together. But the point is that the approach seems to be quite flexible in the way the users want to design their mappings. And also we can, the command line tool allows to use the SPARQL result set as an input. So you can do parametric queries and repeat the same transformation many times with different parameters. We are starting working on improving scalability and performance. For example, we are tackling, we have designed the new execution strategies to support very large files. There is an on-disk option, so we can materialize things on Apache TDB2 before executing the query. And this counts as a command line interface or Apache Gina Fuse key server, and this is open source, so contributions are very welcome. So let's have a quick, before going into evaluation and conclusion, a quick collection of case studies. Okay, these are all reproducible, and there is a set of showcases in the project GitHub webpage. This one elaborates on the CSVs and JSON concatenation. This one is querying the competency questions from the Markdown file. So we can see the Markdown is as a nested set, like our FacadeX, like a document object model. This is a query where we extract a collection or the node sequence from this score. And node sequences are very useful if you want to do some data science with musical data. And with this workflow, we scrape a website, and we build a knowledge graph out of the data from the Irish Museum of Modern Art website. And yeah, all what I've said is has been recently published in one paper in the semantics conference last year, and another one is coming in the ACM transactions on internet technologies, where we start focusing on some theoretical aspects. So how we evaluated all that I said so far. So first of all, there is an empirical element. So like in the physical sciences, you try until it breaks. And actually all formats scrutinized so far are representable with facade X. We have done two theoretical evaluations, one to demonstrate that any format expressible in a BNF syntax can also be represented as facade X, and that facade X can also cover the entity relation model. So we look towards working on querying relational databases at some point. We kind of analyze the cognitive complexity in a bit of a naive method, but I think it's kind of representative. So how many distinct tokens are required to express certain queries, and we have seen the SPARQL Anything as typically more compact mappings than alternative approaches to express mapping rules. And we started to do some performance testing, and full in-memory implementation, which is clearly naive, but is the basic execution strategies we have so far, is comparable to other two Java-based knowledge graph construction engines. But clearly, there is a lot of work to be done into improving performance and scalability. So far, we know that the in-memory implementation scales linearly with the input size, and we know that we can improve performance because we already have implemented a triple filtering approach, which is a quite basic SPARQL optimization. And that we know that we can scale a bit more than the full in-memory materialized approach by slicing the source data, and we have implemented this feature, and we are experimenting on how much this improves scalability, but experiments are promising so far. So how, just to summarize a bit, what are the distinctive features of facade-based data access compared to alternative methods to express mappings like SPARQL Generate and RML? The main difference for us is the killer feature is the fact that if the user is experienced with RDF, knowledge graphs, and SPARQL, essentially there is no other learning demands apart from going a bit through how to understand how to configure the access to these various sources using the SPARQL Anything tool. But there is a huge opportunity for open-ended extendability when bringing in new formats will not require changing the front-facing tool. If the RDF or SPARQL knowledge graph specifications evolve, like we have a SPARQL 2.0, or we have an RDF star, or an RDF whatever, our approach will follow the evolution of basic and standard RDF and semantic web tools. And this will not require to rethink the approach. But clearly, this very, very general approach comes also with some open challenges. And as I was saying, we started about a year and a half ago. So there are so many things we want to look at that we haven't. For example, we so far only covered view materialization. So essentially, we transform everything into the facade, and then we execute the query on the RDF view. But there can be other ways of executing facade X queries. For example, we can study some query rewriting on low-level structures. And clearly, the idea of having a virtual knowledge graph on heterogeneous files and resources is very appealing, but we don't know, it's a completely different beast, okay? Other challenges and directions are related to the nature of the knowledge graphs. So far we worked on structured data, semi-structured data, but clearly there is an increasing interest in this concept of multimodality for knowledge graphs. So there is an open question of how or semi-structured data can be fused and and combined with more structured data into multimodal knowledge graphs. And what does it mean in terms of the knowledge graph construction process? And clearly, building new adapters now, you need to study the FACAD-X problem, you need to study the SPARQL Anything framework and do your coding, but maybe there is a way to improve how to specify mappings from, for example, a BNF syntax to a FACAD-X adapter. And so far, you need to speak SPARQL, clearly. If you don't speak SPARQL, then we can't help, really. But maybe there is some interesting research on user interfaces for facade-based data integration that could be appealing for non-SPARQL users as well, thanks to this kind of very high-level cognitive structures, which is essentially maps and lists and combinations thereof.
You have 1 minute left.
I think I finished. And clearly we are working on new features, so more input formats, relational databases, MIDI, image annotations. Why not? Why not querying images? It would be super cool. And also anything in, but maybe why not anything out? So why we should probably keep SPARQL Anything with a full-fledged template engine, because maybe we want to generate other type of objects other than tabular data or RDF graphs. And this is my big thank you to all the people that are now working and supporting this research, and that have influenced a lot of the things I said today, not speaking, actively contributing with development work and research ideas. Thank you. I finished.
Thank you, Enrico. Yeah, the timer that is ringing. That means that you finished perfectly on time. Okay, good. Now it's time for questions. Is there any questions from the audience? Yeah, Georgia again.
Sorry.
No, it's not Georgia.
You say that like again.
No. Oh no, you again.
No, I was. You said that virtual knowledge graph is a different beast, you know, but I think that this approach, rather than the one that we have seen in the slides in the previous presentation, it can be probably better exploited in the case of virtual knowledge graph. I don't know, probably I have a different, some strange view of that, but you know, you can query anything, you know, using SPARQL. And then you create this intermediate representation in RDF, and then you create with the query your mapping. And so I think that that is a nice idea if you don't have, for example, full control of a data set, okay? Because David before said, okay, companies want materialize the data, right? They don't want really virtual knowledge graph. They want to see the data and touch the data and so on. But if I don't have control on the data that I'm interested in, probably with this approach with SPARQL Anything is really interesting for these specific cases. But you said that, so I was like, oh, probably I didn't understand. Yeah, no. I don't know. What do you mean it's a different beast? So what do you think is required in SPARQL Anything to tackle this topic?
Okay, so when I say it's a different beast, I'm saying that there are important challenges that we haven't thought of yet. Okay, and these are essentially that the virtual knowledge graph concept assumes that data is streamed directly to the client and live somehow. Okay, and there are some important problems if you want to do that with static files. First of all, with SPARQL. Okay, first of all, that with SPARQL you can do joins. So you can express joins from one bit of a CSV file. Let's say, take for example the first row or the second cell of the first row, and you can join that with the last cell of the last row. Okay. The join operation has to be performed and completed before giving back data to the user. And this means that you need to, at some point, the machine has to keep all this knowledge somewhere to perform the fully the join. Okay? It can be in memory, it can be on a temporary database. And this can be extremely challenging and time consuming if you have a very, very, very large data set. But in fact, the virtual knowledge graph, in this sense, nobody's doing it, as far as I know. Maybe David may know more about this than me, but as far as I know, nobody's doing that because it's very complicated. What today is done and is interpreted as virtual knowledge graph is accessing another database. Like if you have a relational database, then the problem is rewriting the query into something that can be run on that database and then stream back the results. And in this sense, this is something that we will work on when we will tackle the relational database connection. And yes, and maybe we will say, yes, we are doing virtual knowledge graphs. I don't know, I haven't done it yet. But that I think is perfectly doable. So virtual knowledge graph over databases is not a problem. I mean, there are problems, but it's something that I can imagine doable. On an open-ended set of static files, well, you need a lot of resources, and you need to take these files, put them in memory, and start playing with these, or using an infrastructure that scales, like, for example, an Hadoop cluster. If you have one CSV of 30 billions of rows, and you put it into an Hadoop cluster, then maybe you can parallelize the query execution through the Hadoop cluster, and you can tackle those numbers. But yeah, but this is a different beast, as I said.
Yeah, okay, thanks a lot, Enrico. Thanks a lot.
You're very welcome.
Okay, next question is by Justin.
Oh, hey, Enrico.
Hi, Justin.
Yeah, I just I'm a SPARQL Anything user, and I've also used RML. And one thing that is, I guess it's a feature of RML that is not of SPARQL Anything yet, is that the mapping is also a graph. And so I do know that with Apache Gena's Arc, you can present a SPARQL query to it, and you can get the SPARQL algebra, which is like a Lisp symbolic expression, which would be pretty easy to represent as an RDF list. But I don't think that would be convenient to query, although you could express a SPARQL query as RDF in that way. But I guess you could also express a SPARQL query using some of the RML or R2 RML vocabulary. I just wonder, have you thought about sort of like bridging the two worlds of like, because on the one hand, it's nice, I think, to be able to type SPARQL really fast. It's very compact. Once you understand it, you can go rapidly through a data source, I think. But at the end of the day, it is kind of nice to have your mapping as data. So I wonder, have you thought about like, bridging the SPARQL construct and the RML, mapping as data worlds?
I think that's a great question. And the short answer is yes. I thought about it. And because clearly there is one advantage of being able to easily decompose and recompose mappings. And that's certainly important. So I started thinking about it a few months ago, and I think there are two versions of this. One is we could let's say we could use a SPARQL ontology when we essentially write a SPARQL query into an RDF graphs, but then I don't know how that RDF graphs would look like, and if I would really like to take bits and compose and recompose this RDF graph, or we need to find something else. We need to invent something else, and where we can take SPARQL operators and compose and decompose them, express them in different ways. I think that's potential on that, and we are thinking about it. That's an important thing. And I also reflected on the potentiality of expressing SPARQL Anything FACADEX mappings in RML, for example. Because if we were able to express FX queries in a way that kind of suits the RML mappers, the RML specification, then we could enable seamless conversion between FACADEX-based data access engines and RML for users that want to express those mappings with RML, for example. So there's a lot of potential. There's a lot of work to do.
Okay, now Alessandro.
Yeah, ciao Enrico. I'll first go with my question and then an observation on what has been discussed so far. So the question is about reusability. As Andrea mentioned before, the fact that everything in RML is a resource means also that it can be easily, immediately reused. Imagine you define a complex rule for building the subject of what will be your triple, and you need to reuse that subject in other parts of your mapping. You will reuse that part, and that's it, because you can use it through its URI, its resource, and so on. What about SPARQL Anything? If you have to reuse a query fragment in another query, that's challenging. I think you have to copy and paste it over, or yeah, okay.
At the moment, you copy and paste it over, frankly, and I think reusability is a very important and interesting topic. It kind of relates to what we discussed before. Software engineering dealt with this problem since forever. Okay, so there are good practices, and there are well-known, and there is a well-known trade-off for reusability. So you want to reuse things, but you don't want to create dependencies, for example. So let's take the case where you only reuse, right? Let's assume that we have our mappings are always and only combination of other mappings. Mm-hmm. Then you will have to deal with dependencies and very complex dependency trees. You will have to handle cycles. You will have to handle troubleshooting. It will not be that easy when you have like a deep and nested structure of interdependent components. You have the problem of evolution. You change one bit, and maybe it may break the whole chain, and then understanding where it is, what this chain is. And often reusability is brought forward because of the value of having distributed knowledge. So multiple people working on different mappings, and then even this creates additional problems, because one can break. The one change to one mapping can break the system of someone else. So there are trade-offs. Okay, and in terms of SPARQL Anything, we haven't thought about how better support reuse, apart from I think Justin proposed a few months ago. Why don't we make queries reusable from within queries? So so that we can develop small queries, and then instead of copying the content, just refer through another query. So, okay, now use that query and then stream over the output into this SPARQL query. I think that's one thing we may implement, because it's easy enough to implement, and we can start to experiment about modularizing mappings and see how it goes.
Yeah, it's not a limitation of SPARQL Anything per se. It comes from SPARQL. We all want to reuse our SPARQL fragments, but we cannot because of SPARQL, not because in this case of SPARQL Anything. So yeah. And just a quick comment. I understand today it was about construction, but I think that the great advantage of this is really in the ability of querying things immediately. So if you want to just join a CSV file and a JSON file, going through RML, it's a different story. You have to build your mappings, put it into the triple store, and then query over it. In your case, you can do it immediately. The fact that you can also construct knowledge graphs is a sort of side effect, or let's say, or something that you get for free because of the approach that you have. But I think the real advantage is to also the ability to quickly express queries and join data without having to do anything special, let's say. So,
I have to pay attention saying this to semantic web experts, because they will start complaining that we are kind of normalizing the idea that you don't need ontologies. you only need the SPARQL and graphs, which sometimes you don't need ontologies. Sometimes you need to build. As I find myself often using SPARQL just because I need to get some data out. We are doing a lot of experiments, for example, with deep learning on images and art and metadata artworks. And the metadata of artworks. So we have metadata in structured files, we have JPEG images, and we need to use all the... So I spend a lot of time producing these CSV tables with all the different features for these different deep learning experiments, and I've done all of it with SPARQL Anything. and there was no knowledge graph construction at all. So you're right. There are cases in which this tool can just be a data integration tool, and a quite convenient one if you are a SPARQL expert. I think that's valid. But again, I will not say this in a pure semantic web venue, because they will start saying that we are making a bad service to semantic web.
No. Okay, thank you. Yeah, it's like Apache Drill, I guess, you know, it's the dual case of SQL. No?
Yeah.
Okay, any other question? Okay, listen, I don't know if your hand raised is new or
It's still the same hand.
oh, still the same. Okay, so actually I have one question for Enrico, because so it seems to me that SPARQL Anything sounds somehow to be an agile methodology for knowledge graph construction that has a number of benefits, but also I would say cons, but there are different perspectives. Let's say I appreciate in the process that you highlighted at the very beginning of your presentation, the iterative workflow in which you separate basically the reengineering, that means transform from the syntactic point of view to data source, so one data source to a different one. Let's say that we move from, let's say, CSV to RDF, regardless to the specific domain semantics that we then want to obtain. And then we introduce semantics by means of remodeling that can be applied as many times we want. So basically, I can obtain the final knowledge graph in several steps. And then I go straight to my question, which is, so as also Alessandro said, in RML, everything is associated with a resource. And accordingly, it seems to be more suitable for designing, also processes like the one you are highlighting, where in SPARQL Anything, which is more somehow agile, and I'm not sure if the definition is correct, but it seems to me in this way. But on the contrary, with SPARQL Anything, in which everything is focused on the definition of SPARQL queries for accessing, transforming, and introducing semantics in my knowledge graph, it's harder to define or to associate clear identifier that can be information objects that can be used for defining transformation processes as it is your initial aim. I don't know if you get the question or not.
I think I haven't.
My question is, how can we? Is it possible to? I go really straight. Is it possible to construct? So to use SPARQL Anything in order to identify clear strategies for generating knowledge graphs by using your solution. So for instance, in RML, I can have mappings, and mappings are in RDF. And I can combine somehow mappings in order to have processes and workflows.
Okay, I see what you mean. I think this is no different in SPARQL. So SPARQL is a combination of operations, of operators that are specified in the SPARQL specification. And each operation has a behavior and has an input, expected input, and expected output. The difference is that this is somehow embedded into the SPARQL specification. And what it is that you don't have is the ability to decompose and recompose these operators. But this comes with, but there are other advantages. For example, you cannot start an iteration, knowledge graph construction iteration with a mapping language without a facade. So let's talk about the facade, not SPARQL and RML, because let's assume that we don't have a facade. Okay, if you don't have a facade, you need to do a configuration before seeing any knowledge graph. So if you have a facade, you can start by seeing the knowledge graph, and then you interact with the knowledge graph until what you see is as close as possible with what you want. And so that's the idea. So the fact that you always interact with the same object, that is the knowledge graph. So if you want to just look at the data source, you do construct SPO, service, SPO. Okay. You don't need to know anything.
No, it's fine. No,
So that's the difference.
I'm wondering if it would be possible to, to use a sort of declarative solution in a sort of, let's say, I would introduce a simple example, a sort of provenance. So I would say, okay, this SPARQL construct with, let's say, with SPARQL Anything or this facade allowed me to generate this graph. Then on top of this graph, I applied another construct that allowed me to generate this other knowledge graph in a way that everything is reproducible and everything can be dereferenced somehow for use purposes. I don't know if it is relevant, but it could be.
I think this is very interesting, and I think it's really about how we can make semantic web programs being documented and explained, and you can apply this problem to RML, to SPARQL, to whatever else.
Okay, thanks.
So, for example, one of the things that they've done, like Albert have done this garlic, and they use this approach of annotating the SPARQL query to decorate the code with provenance. We could think about an approach where we annotate the SPARQL query when we assign URIs to the various bits, for example, and then we query the query. That's perfectly possible. I'm not sure. Yeah, I mean, the problem with this is that you can go as complex as you want, but then there is an ergonomicity. I think. I don't know English enough. Is this a word in English? Anyway,
I see. No, I was interested in this.
Yeah.
I was interested in this. So thanks also, Justin, that pointed me, I think, an interesting reference for this discussion. I was interested in this just because we have a different project in which we are, wondering what could be a nice solution for dealing with the transformation of non-RDF sources to RDF. And we are taking into account RML, R2RML, SPARQL Anything. It also depends. We are also wondering if, all these solutions can be reused and proposed to end user that basically are the data owner that wants to generate knowledge graphs on top of the original sources. And we are also wondering how we can separate, the process from hard coding. So typically now many processes, besides the declarative approach, which is typically used in declarative mappings, but then if you want to combine, as you are proposing, iterative processes in order to derive more knowledge graphs. So I can have one knowledge graph that addresses a specific audience or community. Then I want to derive a new knowledge graph with fine-grained knowledge that targets another community that relies on the previous one. But when we do this, then we typically move again on software, on specific functions. And the idea that we want to have is to combine approaches that are more focused on the orchestration of processes and workflows. Like in the project, we were discussing about the adoption of Apache Airflow for this task. And from the semantic web perspective, we were wondering if the orchestration per se, combined with nice technologies like RML or SPARQL Anything that, you know, for instance, SPARQL Anything is excellent because it separates the syntax representation from the semantics. And this is the point. So I would like to, you know, add an additional brick that allows me to do this in a pure semantic way. So I mean,
this observation makes me think at two things. One is workflows. Yeah, there's a huge tradition of workflow languages, including within the semantic web. So you can use a workflow language in order to tackle this complex orchestration or pipelines, and you can have a single RML engines as well as SPARQL Anything engines working together in different phases of your projects in principle. And the second thing that I can think of is the way we are doing the data pipelines in SPARQL Anything, which is essentially by using SPARQL and combining different service clauses. So I can show you, maybe I can show you one example if in a second of a quite rich data pipeline. Yeah, give me one second. But essentially what we are doing is to exploit this ability of SPARQL of building pipelines, okay? And where we can chain different knowledge graph, different data transformation processes. Okay, so for example, in this case, I don't know if you can see my screen.
Yeah, I see.
So here you have because SPARQL execution goes from the inside to the outside and from top to bottom, right? So you have first step, we query a folder, we get the list of markdown files, and then we pass this we read the markdown file through our facade and get the YAML code in the front matter. And then we take the YAML code and we parse it through another facade X. So the YAML code from the snippet becomes a knowledge graph and we can query it. And here we are querying the metadata from the YAML code. Then we build our entities and we project it to the knowledge graph. So in this way, we combine the number of different facades. We actually extracted a piece of content from one object and we interpret it as a facade. So there's a lot you can do with this approach. And if you have this and you have also the ability of reusing queries, as Justin is pushing, then you have quite a nice and flexible workflow language within plain SPARQL.
Okay, thank you. So I think that we are out of time, but I mean, both talks were particularly interesting, at least from my side, but I think also for all of you, according to the questions that you received and the discussion that started after both talks. As for David, I would thank Enrico with an applause for a virtual one at least, which is not a virtual graph.
Thank you.
So, thanks again. I don't know when. I think this is a communication. This is the last seminar of Polifonia before the summer break. Then I think that after the summer break, a new series of workshop will start. So communication will be circulated on social media or mailing lists by, I would say, by Valentina. Bye-bye, and
thank you, Andrea, for sharing the session today.
Thank you very much, Andrea.
You're welcome.
Thank you, David, for accepting our invitation. It's been brilliant.
You're welcome for your invitation as well.
Bye-bye.
Bye-bye.
Okay. Bye-bye. Thank you. Bye.
Bye. Thank you.